Today we are going to learn about the geologic timescale. To start off, the geologic timescale is a timeline that puts major geologic and evolutionary events in chronicle order. We're able to see which types of organisms evolved on Earth first, which organisms have lived more recently, and also put events like major volcanic eruptions and asteroid impacts in the correct order that they occurred. In order to do this, we're going to utilize pages 8 and 9 of the Earth Science Reference Table. You'll notice that these two pages, 8 and 9, work together and they fold out like a book directly in the middle of your reference table. There's a lot going on these two pages, so what we're going to do is take this page by page, and we're going to start off by focusing just on page number 8 first. So in order to do that, we have to learn a little bit about how this page of the reference table is structured. To start off, geologic time is broken up into things called eons, and that's what I have highlighted here in this first purple column. So let's take a closer look at our eons. Eons break up geologic time into large components. To start off, we have to understand how time is broken up. At the top of the chart, we have the label million years ago. That's going to be our unit of time. And you'll see all the way at the top, 0 million years ago, which represents present day. As you go towards the bottom of the chart, you'll see that we have 4,600 as our unit of time. To break this up even further, you're going to see that there are small bands, whether they are black or white. Those small bands separate 100 million years worth of time. And then if you see larger bands, those separate 500 million years worth of time. So this 500 value really means 500 million years ago. This number further down, 2,000, really means 2,000 million years ago, which essentially is the same quantity as 2 billion. Go even further down, now you're halfway between 3,000 and 4,000 million years ago, so we would estimate this to be 3,500 million years ago, which is the same as 3.5 billion. And then finally, we end with 4,600 million years ago, which is the same as 4.6 billion years ago, which is the age of Earth and the rest of our solar system. So now, this bottom eon that takes up a large majority of Earth's history and time is called the Precambrian. This is the Precambrian eon, and it takes up a tremendous amount of time. So it's further broken up into two eons. One is the Archean, which represents time further in the past. And then you have the Proterozoic eon, which is towards the end of that Precambrian period. The more recent eon, which goes into present day, is called the Phanerozoic eon, and you can see immediately that it takes up a tremendously less amount of time than the Precambrian. So now, going even further, we're going to focus specifically on early eons and eras. So we already know about the Precambrian eon, which takes up a large majority of Earth's history, going back into the past, which is broken up even further by the Archean eon and the Proterozoic eon. And now we have something even further to the right of these labels, and these actually belong to the era column. So the Archean era, or rather the Archean eon, is further broken up into eras that we call early, middle, and late. So you can classify certain parts of the Archean as the early Archean, middle Archean, and then late Archean. Going into the Proterozoic eon, we have a very similar backdown. You have the early Proterozoic, the middle Proterozoic, and the late Proterozoic. Going even further to the right, we have specific events that took place during this time that we're able to pinpoint exactly when and during which eon and era these occurred. So we're going to look at an example question. What is the estimated age of the Earth and the solar system? What you do is look exactly for this phrase in the reference table, which is found all the way at the bottom. Then you look over towards the left and you see that this happened 4,600 million years ago, which was during the early Archean, during the Precambrian. Here's another question for you. How long ago did oceanic oxygen begin to enter the atmosphere? So you look for that phrase, and once you find that exact phrase, you look over to the left to get the time, and we're going to have to estimate here to be about 2,200 million years ago, and this was during the early Proterozoic, but also during that Precambrian. So now we're going to take a closer look at that Precambrian. What I just highlighted here in green represents the end of the Precambrian. You'll notice that your reference table, right where that green marking starts, has this dashed line that goes further to the right on page 8. And we're going to focus on this part right now towards that end of your Precambrian period. So specifically, the Precambrian takes up the largest amount of time and is broken up into different eras in eons. But closer towards the end of that Precambrian period, that's when life started to develop, and we have to have an understanding of how to incorporate that onto this page. So if you look all the way at the bottom of what I highlighted here in purple, we have something that says abundant stromatolites. This is what a stromatolite looks like, and it's one of our earliest organisms on Earth. And believe it or not, some of these stromatolites still exist today, which is absolutely incredible. But what we need to focus on is when these emerged onto Earth. So you see next to that word abundant stromatolites, 1,300 million years ago. If you follow that line and that curve all the way towards the left, you'll see that it developed at that time, 1,300 million years ago, towards the end of that Precambrian period. A little bit more recently, you locate, they call this the Ediacaran fauna. This is when you had the first multicellular and soft-bodied marine organisms. Those came into existence about 580 million years ago, which you can see in our time scale to the left. So when you're in this section of the reference table with that light gray, you have to realize how you have to follow that curve all the way up to the time scale on the left in order to have an understanding of how things worked within that late Precambrian eon. But now we're going to focus on some more recent eras, and this is the basis for the rest of the Earth Science reference table on pages 8 and 9. So we're going to bring it more recently to the Phanerozoic eon. And again, most of this reference table is based on the Phanerozoic eon. It's a smaller amount of time compared to the entire history of the Earth, but it's going to be the entire basis for what we're going to look at for the rest of these 2 pages. Now, the Phanerozoic eon is further broken up into 3 eras. So now we have to see how this reference table branches out just to focus on the Phanerozoic. So the Phanerozoic eon is broken up into the Paleozoic era, the Mesozoic era, and the Cenozoic era. So now let's take a bigger view of page 8. And we have to realize that eons are broken up into eras. Eras are further broken up into periods, which are further broken up into epochs. And from there, you can see what type of life on Earth existed during different time periods of Earth's past. So if we look at this Phanerozoic eon at the top left one more time, we will see that it branches out to take over the remainder of the reference table. So here is your Phanerozoic eon and all of the eras and periods that are included during this chunk of time. So now we have to figure out how time works in this part of the reference table. So I want you to locate near the middle top of page 8 where you see the label million years ago. So we're going to use the same unit of time that we did earlier, but now we're just going to focus on this Phanerozoic eon. Million years ago at the top, you should see the number 0. So 0 million years ago indicates present day. And you follow that all the way down to the bottom where you should see the number 542 million years ago, which is going back into the past. You'll also notice that at that point, if you follow that black, solid, curved line all the way towards the scale on the left side, you'll see that that marks the beginning of the Phanerozoic eon, which was 542 million years ago. Let's take a closer look at some time. So now we're zooming into very specific time periods of the past, the Jurassic, Triassic, and Permian. And you can see the numbers that are listed indicate how far into the past these periods began and ended. So you should see the number 299, 251, 200, and 146. These indicate the beginning and end of these specific periods. For example, when you're going back in time on the reference table, further into the past means you're further towards the bottom of the reference table page. So our first period, the Permian, began 299 million years ago. And then it ended 251 million years ago. But when one period is ending, another one is beginning. So as the Permian is ending 250 million years ago, the Triassic is beginning. Then the Triassic ended 200 million years ago, but then that was the start of the Jurassic 200 million years ago. And then the end of the Jurassic was 146 million years ago. You can also mark with time when certain events took place. So for example, there have been many mass extinctions throughout Earth's history. One of the most notable was the mass extinction of many land and marine organisms, and that occurred 251 million years ago, which marks the transition between that Permian and Triassic period. So now we're going to look at some example questions to figure out how to use this reference table to find out more information. So to start off, our question is, how many million years ago was the mass extinction of the dinosaurs? So on the Life on Earth column, you have to find that exact phrasing. You look for mass extinction of the dinosaurs, which I have highlighted here in pink. If we zoom in and take a closer look, we find the mass extinction of the dinosaurs, and you can see exactly what time that happened, which was 65.5 million years ago. So for our next question, in which epoch, period, and era did the earliest birds appear? So you find that exact phrasing in the reference table. We look for earliest birds in the Life on Earth column that I have here highlighted in orange. If we zoom in and take a closer look, you find earliest birds, and then you look over to the left to the epoch, period, and era columns, and you should see that earliest birds happened during the late Jurassic, during the Mesozoic era. All right, here's one last example question for us right now. In which epoch, period, and era did the earliest fish emerge? So in the Life on Earth column, you search for where you can see the earliest fish, which is going to be all the way towards the bottom. Let's zoom in and take a closer look. You find earliest fish, then you look over to the left to the epoch, period, and era columns, and you should see the epoch is middle, the period is Cambrian, and the era is part of that Paleozoic. So our final answer should be middle Cambrian, during the Paleozoic era. Now there's one more thing on page 8 of the reference table I want us to take note of for right now, and that's that last column titled New York Rock Record that I have highlighted here in purple. Anywhere where you see a gray or a black symbol represents that there is record in New York State of rocks during each of those periods. So simply put, anywhere you see a symbol within a particular time period means there's rock in New York State that formed during that specific time period. But you'll notice that there are gaps where there's no rock record in New York State during certain time periods. So let's point those out. Anywhere here we're highlighting in orange is showing where there's gaps in the rock record. There's no New York State rock that was created during those time periods. So we need to realize that when you have missing gaps in that rock record, those are examples of unconformities. During these time periods in New York State, there were probably instances of uplift, weathering, erosion, and deposition, which took some of the rock layers out of the rock record and new ones deposited over them in their place, allowing for those gaps in the rock record to develop.